Let's solve one more question. So now guys, what is asking, when 10 gram of 80% pure of CaCO3, means CaCO3 is not completely pure, it's not 100% pure, it is having some impurity of 20%, right? So that we have to keep in mind, is decomposed to give calcium oxide and CO2, then how many molecules of CO2 will form? So let's see the solution. First we have to find how much calcium carbonate actually we are having, and that is weight of calcium carbonate, and that will be equal to this 10 divided by 100 into 80. So this much calcium carbonate we are having, and that is equal to 8 grams, right? So let's find out the number of moles. Number of moles of calcium carbonate and that is equal to the given weight, that is 8 gram upon 100 is the molar mass of calcium carbonate, therefore it is equal to 0.08 moles, right guys? So let's write down the equation of decomposition of calcium carbonate. So the reaction is calcium carbonate gives calcium oxide and CO2, right? So now initial number of moles of calcium carbonate is 0.08, and since reaction is not started till now, these will be 0, right? Then final number of moles, that will be equal to, since CaCO3 is decomposed, it is 0, and calcium oxide will form, it is 0.08 and it is also 0.08. So CO2 which is forming, the number of moles of CO2 is 0.08. Let's find out the number of molecules of CO2. So number of molecules of CO2, and that will be equal to 0.08 into Avogadro number, that is Na, and it will be equal to 0.08 into, now we all know that Na is equal to 6.023 into 10 to the power 23. Right guys? So the final answer is 4.8 into 10 to the power 22. So what he can do, he can ask the number of molecules also in the stoichiometry, right? So we will solve these kind of question in this way. Let's solve one more problem.